here we go. For the home play, I'm going to go over a couple of those. Let's go over start with the easy ones. Number 2. We got 9 to the 12 divided by 9 to the 8th. Yes? Are these the same base? Yeah, so it's 9. Since we're dividing now, what happens to the exponents, everyone? Subtract 12 minus 8, that is 4. Okay? Did anybody go a step further multiplying these out? No? Okay. So the next step, if you were to go and continue, yes? Yes? And then that becomes 6,561, if you were to go that far. But when we have big numbers like this, that's fine. You can leave it like an exponential expression, okay? But whenever you have a base of 2, 3 to the power 4, then yes, please simplify. Let's look at number 6. Number 6. For number 6, we have 9 d to the 7th over 3 d to the 6th. Start with the numbers first. Can we simplify this? 9 over 3 is the same as what? 3 over 1, which is 3. All right, are these the same base? Yes. 7 minus 6, that is 1, and there it is. Everybody got it? Okay, let's go to number 8. Number 8, we got w to the 4th, u to the 3rd, divided by w to the 4th, u to the first exponent, or it doesn't show it, but the first thing we should do is what? Put a 1 right there, yes? All right, here we go. Are these the same bases? Yes. So therefore, 4 minus 4 is 0. These the same bases? Yes. 3 minus 1, that is 2. What is w to the 0, everyone? 1 times u to the 2nd. So what is 1 times u to the 2nd? U to the 2nd. On the right, all the way to the right-hand side of your home plate, you have space, don't you? Or if you want to do it in the back, that's fine. Copy this down, please. Example 8q. X to the 7th, y to the 9th, over x to the 5th, y to the 9th. Go. Okay, so you know what you got? Answer x to the 2nd, because we have x, 7 minus 5, that's 2. This becomes y to the 0, and we know that that becomes 1. Is that correct? X squared times 1, and that's how we get that. All right, let's go to number 7. Number 7 shows 12n to the 5th over 36n, and that's it, right? All right, let's go by parts. Let me fix this. Boom. 12 over 36. Can we simplify that? Yes. What does that become? 1 over 3. Are we there so far? Same basis. Put a 1 there. That becomes n to the 4th. Okay. Now, this is the answer, or if we're multiplying, how can we make n to the fourth into a fraction? Over what? Over 1. So therefore, 1 times n to the fourth becomes n to the fourth. 3 times 1 becomes 3. If you got this, that's fine. I'll take that. But if you can go a step further, just making it one fraction, write it as one fraction. Copy this down on your paper, 7q to 8x to the 9th over 32 x to the 3rd. Go. All right. Check with neighbors, see what they got. What'd you get for that one, Zoe? Okay. Go ahead, Tony.
X over 4 to the 6th power.
X over 4
To the 6th power.
to the 6th power.
Yeah, it's X over 4.
Oh, x over 4, sorry. X over 4 to the 6th power. Oh. X to the 6 over 4. Like that? Okay. Hands, if you got that? That looks about right. Here it goes again for those of you that didn't see it. Can we simplify 8 over 32? Yes, we can divide by 8 the numerator and denominator, right? And that gives us 1 over 4. These are the same base. 9 minus 3, that's 6. And if we multiply these two together, we get that. We got it? And last one from the home play, let's go over number 11. Number 11 says negative 21 w to the 5th u to the 2nd over 7 w to the 4th u to the 5th. So let's start with the numbers. Are they the same sign? No. The answer is a negative. 21 divided by 7, that is 3. Are these the same base? Yes. 5 minus 4, that is 1. Are these the same base? Yes. 2 minus 5, that is negative 3. Hands if you got that. Okay? We got this, right? All right. Yes, Jimmy. Okay. All right, so set that aside. The corrections and the signatures, I'm picking those up tomorrow because I want us to get through the next property. So get a Cornell note ready, please. You do not need the Freyer model. We do not need the Freyer model. Tell your neighbor what I just said. Here we go. Our objective for today, I can simplify exponential expressions using division properties of exponents. Let's read together. 1, 2, 3. I can simplify exponential expressions using division properties of exponents. So today we're going to finish with division properties. But we're still on exponential expressions. That's why we don't need a Freyer model. You already have these notes. And we said that exponential expressions are numerical variable expressions raised to a power greater than 1. The steps I said were the same as the multiplication steps except for the two properties, quotient of powers, power of quotient. So we already know quotient of powers. Today we're going to cover power of quotients. But there's one more set of problems that I want us to cover. Yesterday we did these. We did C. Does everybody see that? Okay. And I think we left off here. Did we do this one? Okay, copy this one, please. It says, example 2A, simplify, parenthesis, 3 times 10 to the 10th, close parenthesis, divided by, parenthesis, 6 times 10 to the 6th, and write the answer in scientific notation. Copy that, please. All right, here we go. Look up to the screen. Let's do this one together. Isn't it division? Yes. So let's set it up how we had the other one set up. We write 3 times 10 to the 10th divided by 6 times 10 to the 6th. Does that look familiar now? Yes. All right. So let's do this one together. Let me change the font on this. Can we simplify 3 over 6? What is that, everyone? 1/2. 1/2. Times. Are these the same base? Yes. So that is 10 to the what? To the 4th, because it's 10 minus 6. Is that correct? All right. However, look at the instructions. They want this in what? Scientific notation. So is this scientific notation? No, we need to change this to a decimal. We know the equivalent decimal is what? 0.5. I'm going to put 0.50 times 10 to the 4th. But still, this is not scientific notation. Tell your neighbor what you need to do, please. What do we need to do, everyone? Move the decimal once more. So we need to move the decimal once over. And we went to the right, which means what do we do here to the 4th power? Subtract 1. So this ends up being 5.0 times 10 to the 3rd. And that is scientific notation. Everybody got it? All right, copy this next one on your paper, but then I'm going to push the blank screen on your iPad so you can do the work on the iPad and send me the answer. Here he goes. Copy this one on your paper. 3.3 times 10 to the 6th divided by 3 times 10 to the 8th. Everybody copy that? You don't need to copy the words since you already have them. Just copy the parentheses. 3.3 times 10 to the 6th divided by 3 times 10 to the 8th. Everybody got it? All right, here goes the blank screen. So copy that and do that by yourself. So to get started, I need to rewrite this. 3.3 times 10 to the 6th over 3 times 10 to the 8th. I start with this. It's division, right? 3.3 divided by 3. Does 3 fit into 3? Yes. 1 time. This has got a decimal, okay. Bring down the 3. Does 3 fit into 3? 1 time. All right, so this is 1.1. Times. Are these the same base? Yes. 6 minus 2, minus 8, that is negative 2. Is this scientific notation? Mm-hmm. Yes, it's got 1 digit on the left, and we got our base 10. Okay? All right, so set that aside. Let's move on. Write on your paper, power of quotient property. Power of quotient property. Whoa. Example Q. Here he goes. Parenthesis, 3 to the 6 over 3 to the 4th, close parenthesis, raised to the 3rd power. Underneath that, copy this, parenthesis, 2 to the 3rd over 3 to the 4th, close parenthesis, and that one raised to the 5th power. All right. So here goes the rule. Writing utensils down. Here he goes. Look up, please. Ready? All right. The power of quotient property goes as follows. Let's see if it works with this one. All right, tell your neighbor what the rule is. Let's see, who remembers what it's called when we have a parentheses and another exponent outside? What are we doing? We are doing what? Starts with the letter R. Who remembers? We are, yes. No, not quite. We are raising to another power. Remember that? All right, so we got that. However, look up really quick. So that was the power of quotient property. But yesterday's property was quotient of powers. Look at this one. Can I simplify this one? Are they the same base? Yes. 18 minus 12, that is 6. So that's the quotient of powers. But the power of quotient, you already saw how it works. Copy that. And I'll start writing down here my asterisk and my heart. Oh. So we're still dividing, is that correct? So when dividing, what are we dividing, everyone? Okay. What are they called, everyone? Exponential expressions. But in this case, what's happening? What is that called when we have the parentheses and the exponent? Raised to another exponent, comma. It says, when dividing exponential expressions, raised to another exponent. Everyone? Multiply the exponents. My goodness. Period 10Q. Yeah? Everybody seems like tired. You guys want me to get you guys some Starbucks cups with water? Yeah? Because they're free. You guys notice that? When you go, you ask for water, they're free. Anyways. Bam. All right, so I'm going to leave that up there while you guys finish copying that, and let me switch to Nearpod, and I'm going to forward the next screen, copy the next problem, do that one. Let's see. Copy this one, please. Example 4A. Should be on your screen. Now refresh your browser. Copy that and simplify. And go. All right. Let's see. Four over 7 to the second power. We have exponents of 1, is that correct? That becomes 4 to the second over 7 to the second. Is that correct? Can we simplify a little bit further? Yes, what is 4 to the second? And 7 to the second? There you go. Okay. Copy these next ones, please. Example 4b. Copy that. See if you can do that one by yourself. Parentheses 3d squared over EF and all that raised to the 4th power. Copy that and go. All right, let's see. For those of you that are still having some doubts on this one, look up. You put a 1 on everything that does not have an exponent. Is that correct? You distribute. This becomes 3 to the 4th, d to the 8th. Is that correct? The denominator becomes e to the 4th, f to the 4th. Am I done? No, I'm going to try and simplify this a little bit more. What is 3 to the 4th? 3 times 3 times 3 times 3, which is 81, d to the 8th, e to the 4th, f to the 4th, and we're done. And so you got that? Okay. All right. Let's do one more of these. How about this one, 4C. Example 4C. Let's see how you do with this one. See what I did there? You're like, see. Huh? What?
We're too tired to laugh.
Oh, okay. Copy that and go. Oh, by the way, on this one, simplify the denominator first, and then do the power quotients. Go. Negative exponents. Write that down, please. So today, since I'm going to explain negative exponents from this point forward, we don't need any negative exponents, okay? But I just want you to see as to why the negative exponents become positive exponents, now that we've covered division. Okay, copy this down. Let's do 3 to the 4th power over 3 to the 6th power. So if you were to use the rule that we just learned for division, are they the same base? Yes, so then it's 3. What is the exponent? Negative 2. Are we there so far? Okay. All right, so here goes as to why this becomes positive. Pencil down, eyes up here. Here it goes. If I was to write this in factored form, 3 to the 4th becomes 3 times 3 times 3 times 3. Is that correct? 3 to the 6th becomes 3 times 3 times 3 times 3 times 3 times 3. Is that correct? And we know all these are 1s. Yes? So the simplest 1 that we can think of would be 1 over 1. Is that correct? So what's left in the numerator? 1. What's left in the denominator? 3 to the 2nd. So what are we implying? We're implying that if we use factored form, we end up with a positive exponent. If we use the rule, we end up with what? A negative. However, now that we know the fact that if we use factored form, we end up with a positive, from now on, whenever you have this, it turns into this. Does everybody see that? Copy that, please, so you can have it as reference. So example, super Q. If I was to give you 4 to the negative 5th power, if I gave you over here 3 to the negative 2, it became 1 over 3 to the positive 2, right? Therefore, this becomes what? 1 over 4 to the 5th power. Piece of cake? All right, now let me push your noodle a little bit. Yes? For right now, you can leave it like that. I just want to get to the negatives. So look up. What if I had this? 3 to the negative 2nd over 4 to the negative 5th. Okay? So therefore, we know this one goes down here, yes? But this one's already down here. Therefore, that goes where? It becomes 4 to the 5th. Are we there? Okay. All right, so then now that we got the hang of this, let me give you another one. Example, mega Q. Yes. Here he goes. Let's do x to the negative 5th, y squared, a to the negative 3rd, b to the 4th. Rewrite that, please, without any exponents that are negative. Okay, volunteer. If we get it right, we're done. If not, we go more examples. Felipe.
Y to the second power.
Y to the 2nd power,
B to the fourth power.
b to the 4th power, over
X to the fifth power.
x to the 5th power,
A to the third power.
a to the 3rd power. Hands, have you got that? That is incorrect. They need to be in what? Alphabetical order. B to the 4th, y to the 2nd, a to the 3rd, x to the 5th. Please, pretty please. Okay, so for home play tonight, finish up the play sheet all the way to number 26. It's only 14 of them. So as soon as you put away your iPad, have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.